Who get the answer for number one?
A.
A or B or C or D?
A.
Okay, you get A. Someone else.
A.
Two people get A. Okay, now I can telling you. We already learning about by DC bias. So if you're looking into this circuitry, what type of the DC bias? What type DC bias?
That fixed bias?
Telling me what type of the bias?
Chào nhau rồi vĩnh biệt ngày buồn.
What type? Okay. This is a cell bias. The thing is you don't see any power.
Yeah, cell. Yeah.
Okay. And now you can telling me VB equal VB right here.
0.
VB 0.
0. Yeah.
VB 0. However, you understand it for the cell bias, you need the graphic. However, we don't give your graphic. Okay? So they have to give it to something else. That means they given you VS 1.5 volt.
Oh, yeah.
Okay? So you get the VS equal 1.5 volt. That will be helping you to calculate the IS. Also the same ID all the time. And V equal VS divide IS. Okay, so they will be equal 1.5. Okay, let's see. To answer the fourth question, okay, now you can just that one level here. Yeah. And now you get a VGS equal by basic definition. What VGS equal?
BG minus BS.
VG minus VS. Is it
Yeah.
correct?
Yeah.
Equal VG 0, right?
Yeah.
Minus VS. Okay. And that will be equal what?
Minus 1.5. Yeah.
Exactly. Minus 1.5 volt.
So the answer is B.
B. Okay. The answer will be B. Okay. Next one. ID. If you say IDIS will be the same. Okay. ID equal IS equal 1.5 divide 680 0.680. What you get?
2.2 milliamp.
That will be A, right?
2.2 milliamp.
Exactly. Okay, number 3, BD. How do we get the VD?
VDD minus BRD.
Let's see, VD equal VDD minus
ID
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 RD.
times
IRD.
RD. Okay, so what we get?
Growing in confidence. Reason to feel concerned though. Because confidence maybe give way to a little bit of hubris. Very early, mistaking your claim here in these conditions and with the class of opponent just behind us.
And there's Jeff Kesho just off the back of that main group of Kenyan. We're selling Jeff Kesho is probably the third ranked of the Kenyans this year's 948. 20th at the World Championships last year. Paris Marathon winner this year. So
Yeah, she was an impressive winner of that race. I saw it, and it doesn't quite get the Paris Marathon. At least it's
4.1.
very early, so we've already lost.
Exactly. Okay, and the last one. VDS. VDS equal VD minus VS.
$2.6.
Perfect. The answer will be A. Okay, so anyway, when you look into the circuitry, you have to recognize there will be a fixed bias, cell bias, voltage divider bias. Cell bias and the voltage divider bias, they need a graphic. And normally, we're not solving with the graphic, so that's why they must be given something. For example, for this one, they have to give you the VS, okay? Now, next one. This is a voltage divider bias. And you understand they given you VD. Okay? So we don't need the graphic. So what VG equal? VG is just a voltage divider. VG equal
BDD
DD
plus time
times
R2
R2
divide R1 plus
R1 plus R2. You guys do calculation. I just give formula. Which one?
$1.5.
1.5.
5,
5-4.
4.
Right?
Yeah.
Okay, good. Try to not get the next one. Anyone get it? Try answer. We can keep moving. Okay, we don't want to stay too long. They want ID. If you're looking into that circuitry, you can see ID equal VDD minus VD. Okay, and that will be divided to RD. Okay, so number 2. Who get number 2?
Three point 1.7.
Tell me A, B, C, D. You already get the formula. Only you need to do calculation. But I think that could be A. Correct?
¿Por qué digo Pinkel?
Number 3. Number 3, they want VF. Okay? VF equal IF times RF. Okay? And IF ID will be the same. We already get the ID. Okay? Equal ID times RF. Okay, number 3, A, B, C, D.
B.
Perfect. B. Number 4. VGS. VGS equal VG minus VS.
Is it A?
VGS equal VG minus VS. Let's see, VS 4. VG 1.54. I think they should be C. Correct? The
D.
VG,
D.
let's see, VG, you get 1.54 minus UVS 4. That's why you get negative
Negative 2.46.
92.
Let me check. Let me check.
Why is it 9.2 instead of 4.6?
You do calculation for me. You take the 1.54 minus 4.
Yes, sir, it's D.
Okay, let I try. Okay,
Yeah, it's D.
1.54
It would be D.
minus 4 minus
Professor,
246. Sorry,
can you hear me?
here. Okay, number 5. Number 5 VDS. VD minus VS.
C.
You already get a VD.
2 volts.
D, right?
Yes, sir.
Okay. So basically, I just telling you, okay, how the test will be look like. Okay. So quickly we can go to last one here. Quickly get it done. First thing they want, VG. VG equal VGG, right? This is a fixed bias. And they equal minus 1.5. Okay, fixed bias. Okay, go ahead and do number 2 for me quickly. Okay. VGSQ. VGS equal VG minus VF.
C. Minus 1.5.
Number 2 will be, is it C? Okay, and the next will be ID. Okay, if you want to calculate the ID, you have to using the formula.
Yeah, the formula.
Okay, so I've given you the answer. You guys have to work it out. Otherwise, we don't have enough time. Okay. And number 4, VD. I think the ID equal IDSS 1 minus VGS.
Is it D?
VGS off. Just a minute. And square. Okay, you say number 4 will be which one?
The D?
Perfect. D. That one. Number 5.
C.
A, B, C, D.
C.
Answer will be C, right?
Yeah, C.
Okay. So basically, you can get about 50 questions. And when you need the formula, and the test will be given you the formula. Okay. However, the time will be limited. They given you 3 minutes for one problem, or maybe 4 minutes. We'll see. Okay, any question, anything? If it's not, then I will be stuck with the JFET amplifier. So I need to stop share here. Okay. So now we're talking about JFET amplifier. The same thing like bipolar transistor. First, they need the DC bias. And the second one will be amplifier. In the bipolar transistor, they can get common base, common emitter, common collector. In the JFET, the same thing. They get a common source, common gate, and a common drain. Okay, let's see. JFET are commonly used to amplify small AC signal. Okay, one reason for using a JFET instead of bipolar transistor is that very high input impedance can be obtained. A big disadvantage, however, is that the voltage gain obtainable with the JFET is much smaller. Okay, so the gain for the JFET is not really good like bipolar. JFET amplified configuration as following: common source, common gate, common drain. Okay, you do AC analysis. Remember these 4 steps. Same thing like bipolar, okay? Set on DC source to 0 and replace them by a short circuit equivalent. Replace on capacitor by a short circuit equivalent. Remove on element bypass by the short circuit equivalent. Okay, as introduced by step 1 and step 2. Redraw network in more convenient and logical form. Basically, your guide technician. Okay, so you don't have to go detail too much into AC calculation. However, you have to know how to calculate it when you get the circuit and the formula. Okay, so now FET AC equivalent. This is a DC bias, and you see this one. AC, you will be seeing this schematic. You can get the gate in here and the drain, and also this is the source. Okay, so from the gate to the source, you get the VGS positive, negative, and in the drain into the source, you get the current. That value will be Vm times VGS. RD here, okay? This is the internal resistance of the JFET. We don't need that, okay? So we will be working with now. Calculate about RD, okay? FET input impedance. That means the input impedance you're looking into the FET, you can get the infinity ohm. That's just telling you they get a very high input impedance. FET output impedance, EL, okay, they will be equal that one here, but this one we're not using, okay? Internal RD, that's what we're not using. Where lambda OS is a component of an admittance. Equivalent circuits normally have the range of 10 to 50 microseconds, okay? But that we don't care about that one. Never calculate that. Now, first thing, we're talking about common source amplifier. When you're looking into the circuitry, you need to recognize common source, common gate, or common drain. Normally, you apply the job interview, they just asking you that thing. They don't have asking you to do calculation. Okay? This is they using what type of the bias. Okay? You know, you get the negative voltage here. So they can using fixed bias to build common source amplifier. They can also using the cell bias to build a common source or voltage divider bias. That doesn't matter. However, in this circuitry, they're using fixed bias. Okay. Normally, when we're talking about amplifier, then we're talking about input impedance. That's the first. Output impedance, second thing. Okay, and now if you're looking into here, C1. Who knows the name for the C1?
Problem.
DC blocking or AC coupling. That will telling you at the input, that means signal here. Okay, the AC they get did go. However, any DC from the input they will blocked by C1. That's why C1 same thing like bipolar. DC blocking, AC coupling. Same thing C2. The thing is when you're doing a calculate the DC bias, you can get the VD DC voltage here. And also the signal coming in sideways. And also you can get a sideways. Okay, at the drain. However, the output here, that go to the speaker. You don't want any DC. So that's why you need capacitor C2. Same thing. DC blocking and AC coupling. Okay, so if you get any questions, just let me know. Now, we're talking about input impedance. This is your input here, apply signal here. That means from here you're looking into the amplifier. Whatever resistance you get, that's what they call an input impedance. And this is the output here. You're looking into the amplifier. That's what they call an output impedance. Okay? And also in here, they already telling you, input signal applied to the gate, output is taken from the drain, input, output, out of phase. That's what you need to know, okay? And try to memorize that. Okay, so now they're doing a calculation, okay? They do the calculation. Input here, XC equals 0 ohm, the thing that they shorted capacitor. That's the AC signal. They shorted, okay? And you don't see any battery here. The thing AC, they will be shorted to route. Okay, at the output here, okay? So basically, you can see you still get the current from the drain to the source. And the value will be GM times VGF. And you don't see any VDD here. The thing is battery VDD. Shorted to the route, AC route. Now, what they calculate? Calculate the voltage gain AV. First thing, if you want to calculate the V out will be equal minus GM times VGF, that means the current, times output impedance, G0 equal RD. Okay, that is how come they get the negative. The reason is V out will be measured from here to the route. Okay, and the current ID, they go this way. So voltage and the current opposite. So that's why they get negative. VGF, that means VGF, that means from here to here. VGF equal V in. Okay, that means equal that voltage here. Therefore, V out will be equal minus GM times V in times RD. And if you want to calculate the voltage gain AV equal V out divided to V in, so they will be minus VM times RD. If the load including then AV will be equal V out divided to V in, okay, equal GM minus GM times RD parallel with our load. The thing is, in here, okay, they just given RD, so that will be RD. However, if you get a load, they will be parallel, same. Okay, now you can see that one here. Let's see. Example, the fixed bias configuration at an operating point defined by VGS minus 2 volt, ID 5.625 milliamp, IDSS 10 milliamp, and VGS minus 8 volt. That will be VGS off. Okay, in the textbook, they get a VP, but that's normally VGS off. The thing is, I'm using the textbook from the one university. Okay. Now they want to get the GM and they find the RD. Now we don't need the RD. Okay. RD, that means the internal resistance. And they want to know G in, they want to know G out, and they want the gain. Okay. And also for the gain, ignore FHRD. We said we not count anything related to RD. What RD? RD, that means internal resistance of the JFET from the drain. Okay, let's see. Okay, so this circuitry, same thing. We already done. Okay, and now they given on of the data, the value. Okay, so this is a common source. You get the input 0.2 volt peak to peak. Capacitor here, that will be 1 mega ohm. Okay, and also they're telling you they get the capacitor here. You get the gate. Okay, this is the gate. Gate right here. That will be the source right here. That will be the drain. Okay, and that will be a V out. If you're looking into the circuitry, what type of the bias, DC bias? What type of DC bias for this circuit?
Self.
You get it? Let me know.
Self.
You remember you get 3 different. First thing, fixed bias, cell bias, voltage divider bias. So for this circuitry, which one? Which one? You have to know what DC bias circuitry using. So you have to calculate the DC bias before you can do any calculation for the amplifier.
Self bias.
Cell bias.
Self bias, yeah.
The thing is, you see, you don't have any power here, right? Cell bias. And again, cell bias, you need a graphic. If they not given you a graphic, can you tell me what they given you in this circuit? What they given?
Yes is 1 volt.
Perfect.
Yes, yeah.
You know. Right here. Right? They given a 1 volt. Okay. So if you get a 1 volt for VF, can you calculate the IF? Okay,
Yes.
you get the VF equal 1 volt. Okay. That will be telling you you can calculate the IF and the same with the current ID. IS ID on the time equal VS IF. Okay. That's how you can get current ID. My question is, this capacitor will be a DC blocking or AC coupling. This capacitor the same thing, DC blocking, AC coupling. What happened to this capacitor? What's the name?
Bypass capacitor.
Bypass.
Bypass. Yeah, yeah, bypass capacity.
This is a bypass. Bypass capacitor. Okay, now next one. You say bypass capacitor. Bypass what? What that capacitor bypass?
RS.
Perfect. That's only telling you. You see at the gate, you can get sideways. And when you get to the drain, you can get a sideways, but they opposite polarity. Okay. However, BF, you don't have any sideways. The reason is they bypass. They short AC signal to the route. Okay? So when you measure the AC voltage here, you're supposed to get 0, nothing. That signal be shorted to the route through the C3. The capacitor AC, they shorted just like the wire. Okay? And if you see, if you're looking for input into the amplifier and the input impedance will be 1 mega ohm. Okay? And when you're looking output impedance this way, okay, V out. Who can telling me equal what?
RD parallel RL.
Perfect. You really understand. That's what I like. Okay. RD. Parallel. RL. Okay. Okay, let's see. Any calculation. Okay, they just given you everything. It's not any calculation here. Okay, now this is the one. First one, GE. Okay, equal RG. G out. This one here. I already telling you. We not do anything with this guy. So this one is not using. Okay. If you get a G out in this case, you get only RD equal RD. Okay, now for the gain, okay, AV equal V out divided V in, and they will be equal. This is the formula. Okay, and this one not using. Reason they using RD right here. Okay, phase relationship, common source amplifier. Configuration has 180 degrees phase shift between input and output. Okay. And now this is a common source amplifier they given. Okay, everything, and that's what they doing on the calculation. Okay, let's see. And also, this is common source. Okay, quick question. What type of the bias? What type of the DC bias for this circuit?
Is it ID equals 1.95 milliamps?
No, the thing is what type of DC bias? Answer that. Good.
Self
Self bias. Okay. Cell bias, you're supposed to using the graphic, but they not give graphic. What they given to you?
ID.
ID. Perfect. They given you ID 195 milliamp. Okay. If you get the ID here and the same IS here, that's easy to calculate the VS. Is that right? You calculate the VS equal ID. Times RS. Basically, IS times RS, but IDIS all the time they equal. And you know that here, VG right here. That will be S right here. That will be the drain. Okay? So now if they say they want VGS, I just quickly turn to VGS, VG minus VS. You already know VS and VG is 0. That's a DC we already calculated. Okay? So basically, the guy need to spend a little time, okay, working on this kind of the example. Okay? And next meeting, I will be go through let you know the answer. Okay? And how do we calculate it? That only thing what you did. Okay? Still common short, okay? A JFET short follower. Now, you go to the short follower. That means common drain. Okay? Common drain. That's input here. That's output here. The difference will be the output now from the source. Okay? And this basically just the AC. Okay? However, they just given to you. Okay? AV. If you want to calculate the gain, this is the formula. Okay? Not using this one. You know why? The thing is they're using R small d. That means this register right here. Okay? We don't do it. And if you get a G input impedance, that input impedance. Okay? If you get the output impedance, this is the formula. Okay? Not using this one. Anything with the R small d. Okay? We don't want to do it. So basically, if you want, okay, to do calculation, then you can get the formula. A common drain amplified configuration has no phase shift between input and output. That means the input output will be in phase. Okay, only common source. Okay, will be our phase. Let's see. Add output add. Okay. Wait, I want to see at the beginning. Common source here. This is a common drain. Okay. that have to take that out. That's a common drain, not common short. Okay? That's why you see here, common drain. Same thing on that guy.
Yeah, the drains to the ground.
Yeah. That's still common drain. Okay? I will modify that. Okay? That will be common drain. I know the thing is, they draw AC. Okay? Output, go. Looking into RF, that's why. You right here. The out, looking to RF. Okay? So that's why I know common drain. This will be a common drain right here. Common drain amplified. That's no phase shift. Okay? And this is a common drain. Okay? If you want to calculate whatever here, D out. Okay? Output impedance. And remember, we're not using this formula. Okay? And also the gain, not using that one. Okay? So this is output impedance. This is the gain. Again, anything with the R small d, forget it. Okay, so basically that will be common drain. Okay? And that's just an example. And they want to know what the GM0, GM, input impedance, output impedance, and the gain. Okay? I try to correct that thing. Oh, okay, I know. This is a title. So that's why. That's basically common drain here. This is a title using for everything inside. It and out. Okay? So this is a common drain, and they get the job name will be a short follower. Short follower has a high input impedance, low output impedance, and the voltage gain is less than 1 or unity. Okay? This is just example to do calculation. And basically, if you want to calculate GM, this is the formula calculate GM. Okay, if you want to calculate the gain, this is the gain formula. Okay, if they want GE, that is GE. You want G out, that is G out. Okay, and let's see. Okay. So basically on the test, I given you the formula. Only thing is you have to know how to do calculated. Okay, last one. Come and get. Okay. So basically, input here, apply to the source. Okay, output from the drain. Gate will be connected to the ground, the thing is common. Okay. Let's see what else here. Okay, this is just given to you the formula. Input impedance, output impedance, and this is the gate. Okay, so basically input applied to the source, and output will be taken from the drain. Okay, and that will be telling you, okay, input impedance here, output impedance. Okay, and this is the current from the drain to the source, Dm times Vs. Okay, so for this is common gate, they want to do calculation here. Okay, everything they already did formula here. D out equal now D, AV equal Dm times D. Okay, and this is just a like example. Okay. Okay, basically, we can quickly next time we'll be quickly go over with the calculation for equal. Okay, common source, common gate, common drain. Make sure everyone know how to do the calculation. So you get any question, anything else to me? So think we can get next week meeting, then we take 2 weeks off for the holiday and return on the January. And that take around 2 to 3 weeks, then we end with the fall. Now, what you need to do, try maximum to do on your left vote. Okay, I have to report it the second week of January to say, okay, you ready to get the Tech 1 certificate and to be a Tech 2. So I know, make sure you try to get maximum on the level. Okay, if you get any question, you can ask the lab instructor, or you can ask me if you are in the class. Look like for next semester spring will be happen the same what we are doing right now. That means Monday, Tuesday, Wednesday we'll be working on the lab. Thursday and Friday will be online. Maybe have to take a very long time to return to normal. I don't think so. Maybe have to be after 2024. Okay, any question to me? Anything? Okay, so you guys get any question to me? Okay, if it's not, so good night, everyone.
Good night.
Good, sir.
Good night.
Bye bye.